Be talking about inverse relations now. The first thing we need to discuss, though, is how to find an inverse, which you would replace the y with x and the x with y. If you have a discrete relation, you're just reversing the order of the values in each point that's in that discrete relation. If you've got a relation that's defined symbolically, so with an equation, then you just interchange the x and the y, and then you solve the new relation for y. And if you have it graphically, then you switch the values of the x and the y for enough points in order to see the new relation. So on a graph, a relation and its inverse are reflections of each other about the line y equals x. So that's a result of the fact that you're switching the x and the y. So that makes it kind of flip across that line where y is equal to x. It's kind of a nice relationship there. Okay, so for our first couple of examples, we're going to start off with some discrete relations, which, as a reminder, that means that it's relations that are just defined by points that are not connected. So it's not continuous. So our first relation here is f. And it's defined as the points 2, 3, 3, -5, 4, 1, and 0, -3. First thing I want to do is state whether or not f is a function. To determine that, I want to look at all of the x values and see if there's any x value that is assigned to two different y values. So my first x value is a 2, and it's assigned to a y value of 3. So if I go through and look, none of my other x values are 2. So 2 is safe. My next one is a 3. I go through and look at the rest of them. None of those are 3. My next one is a 4. Then the only other one there is not a 4. So that means this one is in fact a function. Each of the x's that are there has its own y value. So now we're going to find the inverse. According to the definition that we saw above, to find the inverse, you just take each of the points and you reverse the x and the y value. So this would say 3, 2 instead of 2, 3. And the next one would be -5, 3. The next point would be 1, 4. And the last point would be -3, 0. And then once again, we're asked to determine whether or not f inverse, this notation means f inverse, is a function. So once again, I'm going to look at each of the x values and make sure that it's assigned only one y value. My first x value is a 3. I go through and look, and none of the other x's are 3s. So that 3 is assigned a y value of 2 only. My second x value is a -5. So I look at the rest of the points there. Neither of those has an x value of -5, so that one has its own unique y value also. My next one is a 1. The last point is not a 1. So that means all of the x's in this relation have different y values assigned to them. So that means f inverse is in fact a function. Now we'll look at a second one here. So once again, we have f is defined as this collection of 4 points. And we want to determine whether or not f is a function first. So I'm going to go through and look at the x values. My first x value is a -1. It's assigned a y value of -2. So I'm going to go through and look and see if there are any more x values of -1. Here's one here. That one's assigned a y value of -4, which is different from this one. So that means for this one particular x value, there are two different y values assigned. That right there makes this not a function. So I would say no, f is not a function. So now I'm going to find f inverse still. We can still find the inverse of the relation, even though the relation was not a function. So once again, we'll just reverse the x and the y values. And then we can determine from this one, looking at the x values, whether or not the inverse is a functional relationship. So I'm looking again at the x values. My first x value is a -2. It's assigned a y value of -1. If I look to see if there are any more x values of -2, I find that there's another one here, and it's assigned a y value of -3, which is different from this one. So once again, I've got a single x value, -2, that's assigned to two different y values. So that makes this one not a function. Now in these two examples, the first one, both the original relation and the inverse were functions. And on the second example, both the original relation and the inverse were not functions. But that's not always the case. You could have your original relation is a function and the inverse is not, or vice versa. Okay, now you answer the next couple of questions on the Google form.